The Big Bang did not bang. There was no explosion, no sound, no light. The beginning of everything wasn't a beginning at all, at least not in any way your mind can comprehend. What we call the birth of our universe was instead a silent stretching of nothingness into something, an impossible transformation that defies the very language we use to describe it. The story you've been told about our cosmic origins is, at best, an oversimplification. At worst, it's a comforting lie. And if we've misunderstood the beginning so fundamentally, what makes you think we understand the end? You're floating now, in the void between galaxies. The empty darkness stretches in all directions, above, below, behind, ahead. The nearest star is so distant that its light takes millions of years to reach you. You are more alone than any human has ever been, and in this profound isolation, you're about to witness a truth that few have contemplated. The real death of everything. Not the sanitized version from textbooks. Not the simplified models. The raw, unsettling truth. The universe is not just dying. It has been dying since the moment it began. Every second that passes brings us closer to an end that makes even the most catastrophic scenarios seem merciful by comparison. The comfortable theories you've heard before, the big freeze, the big crunch, the big rip, they're just shadows of possibilities. Simplified stories we tell ourselves to make the incomprehensible seem manageable. The reality is far stranger. Time itself is a construct that breaks down at the boundaries of existence. When we speak of the end of the universe, we're applying human concepts to a reality that transcends our understanding. Consider for a moment, what if the universe doesn't end in a single moment or event, but transforms into something our physics cannot predict, our mathematics cannot calculate, and our minds cannot visualize? You might think you're prepared for this journey. You're not, because to understand how everything ends, you must first unlearn what you think you know about how everything began. The universe was never born in fire. It emerged from a state where the very concepts of space and time had no meaning. A singularity, a mathematical point where our understanding of physics collapses. Not a place, not a moment, a breakdown of reality itself. If you could rewind time, what would you see? A moment of creation, or something else entirely? As you approach that first instant, the laws of physics begin to unravel. Cause and effect become meaningless. The arrow of time dissipates. And just before you reach what we call the beginning, you would encounter something our science cannot yet describe. A boundary beyond which our very questions lose meaning. Let that sink in. We don't know, cannot know, what lies beyond that boundary. And if the beginning exists beyond the reach of our knowledge, might the end also transcend our understanding? Look at your hand for a moment. The atoms that form your flesh were forged in the hearts of dying stars. You are, quite literally, made of stardust. The remnants of cosmic catastrophes so violent they defy imagination. Your existence is built upon endings. Without the death of stars, you would not exist. Death and creation are not opposites in the cosmos. They are partners in an eternal dance. And now, as you drift through the interstellar void, a chilling thought emerges. The universe, as we know it, has already died countless times. With each star that explodes, each black hole that forms, each galaxy that fades away, we witness micro-deaths, rehearsals for the final curtain. The cosmos doesn't just end once. It ends everywhere, all the time, in countless ways. The stars you see tonight are ghosts. Many have already perished. their final light still racing toward your eyes across the vast cosmic ocean. When you look at the night sky, you're not seeing the universe as it is. You're seeing its past, its memories, its obituaries written in photons. What if the true end of the universe isn't a dramatic collapse or expansion, but something more insidious, a gradual fading into irrelevance? Imagine the last star flickering out, the last black hole evaporating into nothing through Hawking radiation. The last atom of hydrogen stretched so far from its neighbors that interaction becomes impossible. Not with a bang, but with a silence so profound it makes the void between galaxies seem bustling by comparison. Or perhaps something even stranger awaits us. Our universe may not be alone. Modern theories suggest the existence of a multiverse, an infinite ocean of universes, each with its own laws of physics, its own beginning, its own end. What if, when our universe dies, it simply fertilizes the growth of another? What if death at the cosmic scale is just another form of transformation, a metamorphosis beyond our comprehension? The concept of vacuum decay keeps physicists awake at night. Imagine our universe existing in a false vacuum state, seemingly stable, but actually balanced on a knife's edge. Somewhere, perhaps right now, a quantum fluctuation could trigger a bubble of true vacuum that would expand at the speed of light, rewriting the laws of physics as it grows. You wouldn't see it coming. You wouldn't feel it happen. One moment you exist, the next, the very fabric of reality has changed. Not just your death, but the death of possibility itself. And there's evidence this might be happening already. The cosmic microwave background, the afterglow of the early universe, shows anomalies that shouldn't be there. Cold spots, unexpected patterns, whispers that our understanding is incomplete. What if these aren't observational errors, but glimpses of other universes pressing against our own? What if they're scars from collisions that have already happened? Evidence that our universe is just one bubble in a seething, eternal foam of realities? You might wonder, if the universe has died and been reborn countless times, what does death even mean on such a scale? Perhaps endings are merely transitions, phases in a cycle too vast for human minds to grasp. But this offers little comfort, for even if the cosmos continues in some form, everything we know and love will still fade away. The Earth, the Sun, the Milky Way, all the art, music, literature, and love that humanity has created, lost in an indifferent void. This is the paradox. At the heart of our existence, we are beings who crave meaning in a universe that offers none. We seek patterns, stories, beginnings, and endings. But the cosmos operates beyond such human concepts. It doesn't care about narrative satisfaction. It doesn't build toward a climax. It simply is. And yet, here you are, made of stardust, contemplating the death of everything. Is this not a miracle in itself? That atoms, forged in stellar furnaces and scattered by cosmic catastrophes, would eventually arrange themselves into beings capable of pondering their own existence? Of asking why? Of imagining what came before and what comes after? As we venture deeper into the true nature of universal death, remember this: your very ability to comprehend these ideas, however imperfectly, is perhaps the universe's greatest achievement. Through you, through your consciousness, the cosmos contemplates itself. Through your fear, your wonder, your awe, the universe experiences emotions it could never know otherwise. So, take a deep breath. The journey ahead will challenge everything you think you know about existence itself. We're about to traverse territories where intuition fails and imagination strains against its limits. We'll venture beyond the boundaries of established science, into the borderlands where physics meets philosophy, where mathematics touches metaphysics. The real death of the universe is not just a physical process, it's an ontological question that strikes at the heart of what it means for anything to exist at all. And to truly understand it, we must first unlearn our most basic assumptions about reality itself. The comfortable fiction of cosmic death, you've been told, is just that, a fiction. The truth is far stranger, far more beautiful, and far more terrifying. Are you ready to find out how everything really ends? To understand the death of everything, we must first understand its life. The universe we inhabit is approximately 13.8 billion years old, a number so precise, so confidently stated in textbooks and documentaries that it feels like settled truth. Scientists measure this age by tracking the expansion of space itself, by analyzing the ancient light of distant galaxies, by studying the faint afterglow of creation that permeates all of space. The evidence seems overwhelming, irrefutable. But what if this certainty is merely an illusion? Time, you see, is not the steady river we experience in our daily lives. It bends, stretches, and compresses. Near massive objects like black holes, time slows to a crawl. At speeds approaching light, it dilates. And in the extreme conditions of the early universe, time as we understand it may have had no meaning at all. Picture the earliest moment we can currently describe. 10,000 feet, 43 seconds, after what we call the beginning. 1/10,000,000th of a trillionth of a trillionth of a trillionth of a second. This infinitesimal instant is called the Planck era, named after the physicist Max Planck. Before this moment, our physics simply breaks down. It's not just that we don't know what happened. It's that the very concept of happening may not apply. The early universe wasn't just hot. It was a furnace where time itself was still learning to move, where the distinction between space and time was blurred beyond recognition, where the four fundamental forces, gravity, electromagnetism, and the strong and weak nuclear forces, were perhaps unified into a single primordial interaction that bears no resemblance to anything in our current universe. You've been told the universe began small and expanded. This mental image of a tiny point exploding outward into existing space is fundamentally wrong. There was no outside for the universe to expand into. Space itself was being created with each passing moment. The fabric of reality was stretching, carrying galaxies along with it, like dots on the surface of an inflating balloon. But even this familiar balloon analogy falters, because a balloon has a center, while our universe, paradoxically, does not. If you could somehow stand outside our universe, an impossibility, but imagine it nonetheless, you would see neither edge nor center. Every point would appear to be the center of expansion. From every galaxy's perspective, all other galaxies appear to be moving away. Not because they're moving through space, but because space itself is stretching between them. If the universe has no edge, then where does it begin? If it has no center, from where did it expand? These questions expose the limitations of human language and thought when confronting cosmic realities. Consider dark energy, the mysterious force accelerating the universe's expansion. We've named it, measured its effects, incorporated it into our models. Yet we haven't the faintest idea what it actually is. This force, which constitutes roughly 68% of everything that exists, remains utterly opaque to our understanding. It's as if we've discovered that most of our universe is made of something that shouldn't exist according to our best theories of how reality works. the universe is not just stranger than we imagine, it's stranger than we can imagine. Now, let's see. Turn to dark matter, another 27% of our cosmos that we can detect only through its gravitational influence. We cannot see it, touch it, or interact with it through any means except gravity. Yet without dark matter, galaxies would fly apart, unable to maintain their spiral structures. The cosmos, as we know it, could not exist. Together, dark energy and dark matter compose about 95% of everything that exists. The stars, planets, nebulae, black holes, all the wonders we can observe, amount to a mere cosmic afterthought, the visible foam atop a dark, unknowable ocean. For a moment, consider what this means. After centuries of scientific advancement, after developing technologies that can detect particles smaller than atoms and photograph black holes millions of light-years away, we remain fundamentally ignorant about 95% of reality. Our most sophisticated theories, the standard model of particle physics, Einstein's general relativity, cannot explain the vast majority of what exists. This is not just a gap in our knowledge. It's a chasm so vast it calls into question whether our minds, evolved to track predators on African savannas, can ever truly comprehend the nature of reality. And yet, despite these profound unknowns, cosmologists speak confidently about how the universe will end. The prevailing theory, the one you're likely familiar with, suggests a big freeze, or heat death. According to this model, the universe will continue expanding forever, galaxies moving farther and farther apart until they're no longer visible to one another. Stars will exhaust their fuel and die. Black holes will eventually evaporate through Hawking radiation. After trillions upon trillions of years, the cosmos will become an endless, cold void where nothing happens and nothing can happen. An eternity of perfect stillness. It's a bleak scenario, yet oddly comforting in its inevitability and simplicity. But is it correct? The heat-death scenario rests upon assumptions about dark energy that may not be valid. What if dark energy is not constant, but changes over time? What if it strengthens, accelerating expansion until it tears apart not just galaxies, but stars, planets, atoms, and subatomic particles themselves? This alternative end, the Big Rip, would see the universe literally tear itself apart, space expanding so rapidly that no structure, no matter how small, could remain intact, or perhaps dark. Energy will weaken and reverse, causing expansion to slow, stop, and eventually reverse. In this Big Crunch scenario, the universe would collapse back upon itself, all matter and energy compressed once more into an infinitesimal point. Some theorists suggest this could trigger another Big Bang, a new universe arising from the ashes of our own in an eternal cycle of death and rebirth. These three scenarios, freeze, rip, crunch, are taught as the primary possibilities, but they share a fundamental flaw. They assume we understand the nature of dark energy, dark matter, and the fundamental forces that govern reality. They assume the laws of physics we've discovered are complete and unchanging. They assume our mathematics can model the behavior of a universe approaching its ultimate end. What hubris! Consider quantum mechanics, our best description of reality at the smallest scales. According to quantum theory, particles can exist in multiple states simultaneously until observed. They can tunnel through impenetrable barriers. They can affect each other instantaneously across vast distances in a phenomenon Einstein called spooky action at a distance. None of this makes intuitive sense. None of it aligns with our everyday experience of reality. Yet quantum mechanics works. Its predictions have been verified to extraordinary precision. It underlies much of our modern technology, from computers to MRI machines, but we still don't fully understand what it means. how to reconcile its probabilistic, observer-dependent reality with the deterministic, observer-independent world of general relativity. This reconciliation, a theory of quantum gravity that would unite our understanding of the very large and the very small, remains the holy grail of theoretical physics. Without it, our ability to predict the ultimate fate of the universe is severely limited. We're trying to write the final chapter of a story when we don't understand the language it's written in. And what of entropy, the inexorable increase of disorder that underlies the arrow of time itself? The second law of thermodynamics tells us that in any closed system, entropy always increases. Order moves toward disorder. Complex structures break down into simpler ones. This law seems to underpin the heat-death scenario, a universe where all energy has dissipated, all structures have dissolved, all difference has vanished. But is the universe truly a closed system? If multiple universes exist, could energy or information transfer between them? Could our universe be nestled within a larger multiverse with its own laws and patterns? If so, what seems like an end from our perspective might be merely a transition from another. The mathematics suggests possibilities even stranger than these. Some equations hint at dimensions beyond the 3 spatial and 1 temporal dimension we experience. Hidden dimensions curled up so tightly we cannot perceive them, yet crucial to the fundamental nature of reality. Other calculations suggest space and time themselves might be emergent properties, arising from deeper, more fundamental phenomena that have no spatial or temporal character at all. Imagine that, a reality where space and time are not fundamental, but derivative, like how temperature emerges from the average motion of countless particles. What would the end of the universe mean in such a context? If time itself is merely an approximation, an emergent phenomenon, can the universe truly have a beginning or an end? When we speak of cosmic death, we're projecting our human experience of finality onto a reality that may transcend such concepts entirely. We're like two-dimensional beings trying to comprehend a cube. We see only slices, shadows, fragments of a more complex whole. So perhaps the question isn't, how will the universe die? But rather, what does cosmic death mean in a reality that may have no beginning or end, at least not in any way we can comprehend? What if the very concept of death is a limitation of our perspective, not an intrinsic property of the cosmos? This is not merely philosophical speculation. These questions lie at the heart of our most advanced physical theories, at the bleeding edge where mathematics, physics, and philosophy become indistinguishable from one another. They challenge not just what we know, but how we know, the very foundations of knowledge itself. As we prepare to explore the possible ends of everything, remember this: certainty is often the first casualty of true understanding. The more deeply we peer into the cosmos, the more mysterious it becomes. And in that mystery lies not just the fate of our universe, but the limits of human comprehension itself. In the vast emptiness between galaxies, something impossible is happening. Space itself is stretching, not into anything, but simply expanding. This cosmic stretching carries galaxies away from each other like islands drifting on an inflating ocean. But this ocean has no shore, no boundary, no edge. And unlike water, which merely carries objects on its surface, space is the very fabric in which reality is embedded. We don't move through space so much as with it, dance partners inseparable from the dance itself. This expansion, the defining characteristic of our universe since its birth, holds the key to its death. But to understand why, we must venture into realms where intuition fails and imagination strains against its limits. Picture a singularity, not as a point, but as a breakdown of reality itself. In mathematics, a singularity occurs when an equation yields infinity, I-80, result that, while mathematically expressible, has no physical meaning. The center of a black hole is such a place. Here, matter collapses to infinite density, and space-time curves so severely that our equations can no longer describe what happens. It's not that something exotic occurs, it's that the very concept of occurring loses meaning. Now consider that our universe may have emerged from such a singularity, a state where density, temperature, and curvature were infinite, a state beyond physics, not a place, not a time, a mathematical boundary beyond which our understanding simply breaks. Many cosmologists believe our universe will end in a singularity, or something approximating one. But what happens at or beyond such boundaries? Here, we enter the realm of theoretical physics, where mathematics suggests possibilities that defy comprehension. Imagine reality as a film reel, where time is not flowing, but every moment already exists. From this perspective, what physicists call the block universe, our perception of past, present, and future is merely an illusion. All moments exist simultaneously, laid out like frames in an eternal film. What we experience as now is simply where our consciousness happens to be focused. In this model, the universe doesn't begin or end in the conventional sense. It simply is, a four-dimensional structure containing all events that ever were or will be. The birth and death of the cosmos are not processes unfolding in time, but boundaries of a static, eternal object. But this raises a profound question. If time doesn't flow, why do we experience it as doing so? Why does entropy, the measure of disorder, always increase in one direction? Why can we remember the past but not the future? Perhaps the arrow of time is itself emergent, a large-scale phenomenon arising from underlying timeless physics, just as temperature emerges from the random motions of particles that individually have no temperature. Perhaps time's flow is not fundamental but statistical, a product of probability rather than necessity. This perspective transforms how we think about cosmic death. The end of the universe may not be a future event, but rather a boundary condition, like the edge of a map. Not something that happens, but something that is. But there's another possibility, one that makes the film reel analogy seem quaint by comparison. What if our universe is just one of many? What if reality is not a single film, but an infinite library of films, each playing out according to different physical laws, different initial conditions, different evolutionary paths? The multiverse theory, once considered speculative fringe, science, has gained significant traction in recent decades. It emerges naturally from several established physical frameworks, including eternal inflation, string theory, and quantum mechanics. Consider quantum mechanics, our most successful theory for describing reality at the smallest scales. At the quantum level, particles exist not as definite objects but as waves of probability. When measured, these probability waves collapse into definite states, a phenomenon so baffling it has spawned multiple interpretations. One such interpretation, the many worlds theory proposed by Hugh Everett III, suggests that every quantum measurement causes reality to branch. All possible outcomes occur, each in its own parallel universe. If true, the implications are staggering. Every decision you've ever made, every coin you've ever flipped, every quantum event since the dawn of time has spawned countless parallel realities, universes identical to ours except for these increasingly divergent histories. In this framework, cosmic death becomes even more complex. Our universe might die, but countless others would continue, some identical to ours up to a point, others wildly different. Death becomes local rather than universal, the end of one branch, not the entire. Tree string theory suggests something equally profound. According to this framework, our universe might be a three-dimensional brain floating in a higher dimensional space. Other brains, other universes, might exist parallel to ours, occasionally colliding in cosmic cataclysms that reset their evolutionary clocks. These are not mere thought experiments. Physicists have identified possible observational signatures of such collisions in the cosmic microwave background, the afterglow of the Big Bang that permeates all of space. The evidence remains tentative, but the possibility cannot be dismissed. Then there's eternal inflation, a model suggesting that space expands exponentially, with quantum fluctuations occasionally causing regions to bubble off into separate universes. In this scenario, our cosmos is but one bubble in an eternally frothing sea of creation. While our particular universe might end, the process that created it continues endlessly, spawning new realities with different physical constants, different dimensions, different fundamental forces. If true, this raises the possibility that universes evolve through a kind of cosmic natural selection. Physicist Lee Smolin has proposed that black holes might spawn new universes, with physical laws slightly altered from their parent universe. Those universes that produce more black holes would, in turn, produce more offspring, leading to an evolutionary pressure favoring universes capable of complex structure formation. In such a scenario, universal death becomes part of a larger, reproductive cycle. Not an end, but a transition. Our universe's demise might simultaneously be the birth of countless others, but perhaps the most radical reimagining of cosmic mortality comes from a theory that questions the very nature of reality itself. What if the universe is not fundamentally physical but informational? What if particles, forces, space, and time are not the base layer of reality, but emergent phenomena arising from underlying information processing? This is not mere philosophy. Theoretical physicist John Wheeler encapsulated this view in his famous phrase, "it from bit," the notion that physical things, it, arise from information, bit. In this framework, the universe is less like a machine and more like a computation, a cosmic algorithm playing out across scales from the quantum to the cosmological. If reality is fundamentally informational, then perhaps cosmic death should be reconceived as well. Rather than a physical end, it might represent a computational boundary, the completion of a cosmic calculation, or perhaps its transformation into something else entirely. Consider the simulation hypothesis, the proposal that our reality might be an advanced computer simulation created by a post-human civilization. While speculative, this idea has been seriously discussed by philosophers and physicists alike. If true, universal death might be as simple as someone switching off the simulation, or as complex as the simulation evolving beyond its initial parameters into something its creators never intended. But even without invoking such speculative scenarios, the informational perspective offers new ways to think about cosmic mortality. If information is fundamental, then perhaps it is conserved even across the death of physical structures. The pattern that is you, the pattern that is Earth, the pattern that is our universe, these might persist in some form even as their physical manifestations dissolve. This connects to a profound question at the heart of quantum mechanics. What happens to information that falls into a black hole? For decades, physicists believed such information was lost forever, a violation of quantum principles that require information to be conserved. Stephen Hawking's later work suggested that information might escape through subtle quantum correlations in the radiation black holes emit as they evaporate. If information can escape the seemingly inescapable gravity of a black hole, might it also transcend the death of a universe? Loop quantum gravity, a theory attempting to reconcile quantum mechanics with general relativity, suggests something equally profound. According to this framework, space itself is not continuous, but discrete, woven from tiny loops of gravitational force. When matter becomes sufficiently dense, as in the early universe or at the center of black holes, these loops reconfigure, potentially creating a bounce rather than a singular collapse. In this scenario, our universe might have emerged from the collapse of a previous one. And when our universe eventually contracts, if it does, it might similarly bounce, giving birth to a new cosmos with new physical constants. Death and rebirth, not as metaphor, but as physical process. The question of how the universe dies, thus, becomes inseparable from the question of what reality fundamentally is. Are we pattern or particle? Wave or information? Physical or digital? The answer may determine not just how everything ends, but what ending actually means. As we venture deeper into these mysteries, we must remember that our understanding is constrained not just by current knowledge, but by the very architecture of our minds. We evolved to navigate the mesoscale world, to track game across savannas, to avoid predators, to manipulate tools. Our intuitions about causality, space, and time served us well in that environment, but may be fundamentally unsuited to cosmic questions. The true nature of universal death might be something we cannot currently conceive, not because it's mystical or supernatural, but because our cognitive apparatus lacks the necessary structures to represent it. Like trying to explain color to someone born blind, or music to someone born deaf, the ultimate cosmic reality might transcend the categories our minds can construct. And yet, paradoxically, it is through human minds that the universe comes to know itself. Through our equations, our observations, our theories, the cosmos achieves a kind of self-awareness. We are the means by which the universe asks, "How will I die?" As we probe deeper into cosmic mortality, we encounter paradoxes so profound, they force us to question not just our theories, but the very nature of understanding itself. These are not merely puzzles awaiting solutions, but potential windows into realities our current frameworks cannot accommodate. Consider the vacuum catastrophe, perhaps the greatest discrepancy in all of physics. Quantum field theory predicts that empty space should seethe with energy, virtual particles popping in and out of existence, fields fluctuating between states. This vacuum energy should be astronomically large, yet astronomical observations suggest it's nearly zero, 120 orders of magnitude smaller than predicted. That's a factor of 1, followed by 120 zeros. No other scientific theory is off by such an absurd margin. If our best theories can't accurately predict the energy of nothing, how can we trust their predictions about the death of everything? This discrepancy isn't just an embarrassing error. It's a profound clue that something fundamental is missing from our understanding. Perhaps additional symmetries or dimensions suppress vacuum energy. Perhaps multiple universes with different vacuum energies exist, and we happen to live in one compatible with our existence. Or perhaps our entire approach is fundamentally flawed. Then there's the black hole information paradox, a contradiction between quantum mechanics, which says information cannot be destroyed, and general relativity, which suggests information falling into a black hole, is lost forever. This isn't merely academic. It strikes at the heart of whether physical processes are fundamentally reversible or whether true loss is possible. For decades, this paradox seemed irresolvable. Then Stephen Hawking proposed that black holes slowly evaporate through quantum effects, potentially releasing their imprisoned information. But how this information comes out, whether it's preserved in subtle correlations in the radiation or through more exotic mechanisms, remains contentious. The resolution may require a fundamental revision of how we think about space, time, and information. A revision that would necessarily transform our understanding of how the universe ends. If information is truly conserved, then perhaps nothing is ever truly lost. Not a falling leaf, not an extinct species, not a dead star, not even a universe. But what would it mean for information to survive the death of its physical substrate? Does pattern transcend substance? And if so, in what sense can we say the universe dies at all? This connects to a deeper question. Is mathematics discovered or invented? Do mathematical structures exist independently of human minds? Or are they human creations? If the former, then perhaps reality itself is fundamentally mathematical, not just described by mathematics, but constituted by it. Physicist Max Tegmark has proposed precisely this, that physical reality is a mathematical structure, not something described by equations, but the equations themselves. If true, our universe exists because it's a logically consistent mathematical structure, and its evolution simply follows the inherent logic of that structure. In this view, cosmic death would be a mathematical necessity, not a physical event so much as a logical conclusion. But it would also suggest the possibility of other mathematical structures, other logically consistent sets of equations representing other possible universes with other possible deaths. This mathematical perspective connects to another profound paradox, Gödel's incompleteness theorems, which prove that in any formal system complex enough to describe basic arithmetic, there will always be true statements that cannot be proven within that system. Might the true nature of cosmic death be such an unprovable truth? Might there be aspects of universal mortality that are true but formally undecidable within our theoretical frameworks? These abstract considerations have concrete implications. Consider dark energy, the mysterious force accelerating cosmic expansion. When first discovered in the late 1990s, it shocked the scientific community. The universe wasn't just expanding, it was accelerating, as if driven by an anti-gravity force permeating empty space. Most cosmologists identify dark energy with the cosmological constant, a term Einstein initially added to his equations to create a static universe, then famously rejected as his greatest blunder when observations revealed an expanding cosmos. Ironically, it now appears Einstein's blunder may have been prescient. But what is the cosmological constant physically? One interpretation connects it to vacuum energy, the same quantum fluctuations that create the vacuum catastrophe. But this raises a troubling possibility. What if dark energy isn't constant? What if it changes over time? Some observations hint at precisely this, that dark energy may be strengthening. If true, the implications for cosmic death are profound. Instead of a gradual cooling and dispersal, the universe might face a catastrophic big rip, where accelerating expansion eventually tears apart galaxies, stars, planets, atoms, and subatomic particles themselves. Not with a whimper, but with a violent, irreversible dissolution of structure at all scales. On the other hand, if dark energy weakens or reverses, expansion might slow, stop, and ultimately reverse, leading to a big crunch where all matter collapses back into a singularity similar to the one from which it emerged. Some theorists suggest this could trigger another expansion, a new universe arising from the compressed remains of our own in an endless cycle of death and rebirth. This cyclical model resonates with ancient cosmologies from Hindu to Mayan traditions, which envisioned cosmic cycles of creation and destruction. But it also emerges naturally from certain approaches to quantum gravity, particularly loop quantum cosmology, which suggests space-time might bounce rather than collapse completely. In such scenarios, our universe wouldn't truly die but transform, like a phoenix rising from its own ashes. Each cycle might have different physical constants, different distributions of matter and energy, different evolutionary trajectories. Our particular universe, with its particular physical laws and structures, would end, but the process that created it would continue. This connects to the anthropic principle, the observation that the universe's physical constants seem suspiciously fine-tuned for life. If gravity were slightly stronger or electromagnetism slightly weaker, if the strong nuclear force varied by just a few percent, complex structures like stars, galaxies, and ultimately biology could not exist. Some interpret this as evidence for a creator or designer. Others suggest it's simply selection bias. In a multiverse with different physical constants in different regions, life would naturally evolve only in those regions where conditions permit it. We find ourselves in a life-friendly universe not because it was designed for us, but because we couldn't exist anywhere else. But the anthropic principle raises a troubling question about cosmic death. Might the universe's end also be fine-tuned? Might the particular way our universe dies be somehow essential to the emergence of life within it? Could there be a connection between universal mortality and consciousness itself? Some theoretical frameworks suggest precisely this. The cosmic, natural selection hypothesis proposes that universes reproduce through black holes, with each black hole spawning a new universe with slightly altered physical parameters. If true, those universes most conducive to black hole formation would dominate the multiverse. Interestingly, the conditions that optimize black hole production also seem conducive to life. Stars must exist long enough and in sufficient numbers to produce heavy elements essential for biology. Galaxies must be stable enough to support multiple generations of stars. Matter must clump gravitationally to form structures, but not collapse completely. In this framework, our universe's particular death spiral, its gradual cooling and expansion, its formation of black holes, its eventual heat death, might be intrinsically connected to the conditions that allowed us to evolve within it. We are, in a sense, children of cosmic mortality. This connection between life and cosmic death extends to more exotic possibilities. Some physicists, including Roger Penrose, have suggested that the extreme conditions following universal heat, death, when all matter has decayed and space has expanded to near infinity, might be mathematically equivalent to the conditions at the Big Bang. What appears as an end from one perspective might be a beginning from another. In Penrose's conformal, cyclic cosmology, each universe's death becomes the birth of the next. The transition occurs when all particles have decayed and all black holes have evaporated through Hawking radiation, leaving nothing but massless particles like photons. At this point, with no massive particles to provide a scale, the distinction between the infinitely large and the infinitesimally small breaks down. The end becomes a new beginning. Penrose has even proposed that evidence of previous cosmic cycles might be detectable in the cosmic microwave background, concentric circles representing ripples from supermassive black hole collisions in a previous cosmic epoch. While controversial, such theories remind us that the boundary between speculative and mainstream science is constantly shifting. Perhaps the most profound paradox concerning cosmic death emerges from quantum mechanics itself. At the quantum level, time behaves differently. The fundamental equations are time-symmetric. They work equally well forward or backward. There's no inherent arrow of time in quantum physics. Yet we experience time as flowing irreversibly from past to future. Entropy increases. Eggs break, but don't unbreak. People age, but don't unage. The universe expands, but doesn't contract. Why? The key conventional answer involves initial conditions. The universe began in an extremely low entropy state, and the second law of thermodynamics ensures a steady march toward higher entropy. But this merely pushes the question back. Why did the universe begin in such an improbable low entropy state? Some theorists, including Sean Carroll, suggest our observable universe might be one half of a symmetric pair, a mirror universe where time runs backward from our perspective. The Big Bang represents not a beginning but a middle, a minimum entropy boundary between two time-reversed cosmic epochs. In this view, what we call the death of our universe might simultaneously be the birth of its time-reversed twin. As entropy increases in our direction of time, it would decrease in the opposite direction. What we experience as cosmic evolution toward heat death, observers in the mirror universe would experience as evolution away from it. This symmetry would resolve the puzzle of the universe's low entropy beginning. It's low entropy from both temporal perspectives, but it would also transform our understanding of cosmic mortality. The end would literally be a beginning, viewed from a different temporal vantage point. Such speculations might seem untestable, residing permanently in the realm of philosophy rather than science. But quantum cosmology continues to develop experimental predictions, however indirect. The patterns in the cosmic microwave background, the distribution of galaxies across space, the behavior of gravity at the largest scales, all might contain subtle clues about the ultimate fate of everything. And sometimes, paradoxes resolve not through new discoveries, but through conceptual revolutions, fundamental shifts in how we frame the questions themselves. Quantum mechanics didn't resolve classical paradoxes so much as dissolve them, replacing deterministic certainty with probabilistic waves. General relativity didn't explain how gravity travels faster than light. It revealed that gravity isn't a force at all, but the curvature of space-time itself. Perhaps the paradoxes surrounding cosmic death require similar conceptual revolutions. Perhaps time itself is not fundamental but emergent. Perhaps causality breaks down at the boundaries of existence. Perhaps information transcends its physical substrate in ways we cannot yet conceive. As physicist Niels Bohr reportedly said, "How wonderful that we have met with a paradox. Now we have some hope of making progress." The paradoxes of cosmic mortality aren't obstacles to understanding. They're portals to deeper insights. Each contradiction, each discrepancy, each logical impasse points toward new conceptual territory, new frameworks, new ways of thinking about reality itself. The death of the universe, it seems, is not merely a future event to be predicted, but a conceptual limit that tests the boundaries of human understanding. In probing how everything ends, we discover the edges of what everything means. Take a breath. Feel the air entering your lungs. Feel your chest rise and fall. This simple act, this exchange of oxygen and carbon dioxide, connects you to the cosmic story we've been unfolding. The oxygen you just inhaled was forged in the nuclear furnace of a star that died billions of years ago. The carbon in your cells was scattered across space by stellar explosions long before our sun ignited. You are not just in the universe. You are of the universe. Its mortality is your mortality. And now you know the truth. This cosmos that birthed, you will someday cease to exist. But what does that mean for you? Here, now. Breathing in starlight, transmuted into air. If time is an illusion, if past, present, and future exist simultaneously in a vast cosmic block, then everything you've ever done, every word you've spoken, every person you've loved, all of it exists eternally, preserved in the amber of space-time. But it also means everything you will ever do might have already happened infinite times before. your choices, your struggles, your triumphs. All predetermined points on a map that was drawn complete at the moment of creation. Are you still breathing deeply? Or has your breath quickened? What if the universe is alive, and we are just its fleeting thoughts? What if consciousness, the awareness reading these words right now, is not confined to biological systems, but permeates reality at scales we cannot perceive? Perhaps what we call the universe's death is merely its transition to another state of awareness. Perhaps, when the last star fades and the last black hole evaporates, the cosmos will not end but awaken, transformed by its long evolutionary journey from mindless energy to something we cannot comprehend. But then, what becomes of you? What becomes of us? Look at your hands. These collections of atoms, these temporary arrangements of stardust, will dissipate long before the universe approaches its end. Your personal mortality, that knowledge you carry with you every day, seems almost trivial when set against cosmic extinction. And yet, they are connected. The processes that will eventually still the last quark are the same that will someday still your heart. The arrow of time that carries the universe toward its eventual fate carries you along with it, moment by moment, heartbeat by heartbeat. There is no escape. Not for you, not for humanity, not for the cosmos itself. Can you feel it? That vertiginous sensation, as if the ground beneath your feet has suddenly vanished, leaving you suspended over an infinite abyss? That's the cosmic horror of our situation. We exist briefly on a tiny world circling an ordinary star, one among billions in a galaxy that is itself one among billions, all racing toward an end we can theorize about but never truly comprehend. Thebai, universe is not just larger than we imagine. It's larger than we can imagine. If the Milky Way were the size of a grain of sand, the observable universe would be the size of Earth. If you could count one number each second, you would need 13.8 billion seconds over 430 years just to count to the age of the universe, and the time remaining before cosmic heat death? Trillions upon trillions of years, a span so vast that if each year were a single atom, all those atoms would form a structure larger than the observable universe itself. Such scales crush human significance to nothing. They render our grandest achievements, our civilizations, our art, our science, into less than dust, less than a quantum fluctuation in an endless void. And yet, here you are, aware, conscious, capable of contemplating the death of everything. Through you, the universe has evolved eyes to see itself, a mind to comprehend itself, a heart to feel the weight of its own mortality. Is this not a kind of miracle? That blind matter, following physical laws, could organize itself into a being capable of asking, how will it all end? What if we are the universe's attempt to understand itself? What if consciousness, your consciousness, is reality's defense against meaninglessness? Perhaps the cosmos created us precisely because it needs witnesses to its grandeur and its passing. Without observers, would the universe truly exist? Without minds to contemplate it, would its death have meaning? Consider this possibility. What if the end of the universe depends on whether it's observed? Quantum mechanics suggests that reality exists in superposition until measured, that observation itself helps determine which potential becomes actual. What if the universe's fate exists in a similar superposition of possibilities, awaiting conscious minds advanced enough to collapse that wave function? What if you, yes, you, through the mere act of contemplating cosmic death, are participating in determining how it will occur. The thought is both empowering and terrifying. It suggests, we are not passive witnesses to cosmic drama, but active participants in it. That consciousness itself might be the wild card in an otherwise deterministic universe, the one thing not fully accounted for in our equations and models. But there's an even more unsettling possibility. What if the universe has died and been reborn countless times already? What if your consciousness, the exact awareness experiencing these words right now, has existed before and will exist again, perhaps in forms you cannot imagine? Not reincarnation in the traditional sense, but a fundamental recurrence built into the fabric of reality itself. Nietzsche called it eternal return, the idea that given infinite time, every possible configuration of matter and energy must eventually repeat, including you, including this moment, including this thought. Feel that shudder running through you? That's the cosmic uncanny, the sense that reality is both familiar and profoundly strange. That existence itself is built on paradoxes we can name but never fully grasp. The heat death of the universe, the Big Rip, the Big Crunch, vacuum decay. These aren't just abstract scientific scenarios. They're potential chapters in your extended autobiography. Your atoms, the energy patterns that constitute your being, will be present at the end of everything. Not as you, perhaps, but as participants in whatever final state awaits. You are made of the universe, and to the universe you will return. But in between, in this brief, luminous moment of awareness, you have the capacity to witness, to wonder, to contemplate your place in the cosmic story. This is the terrible privilege of consciousness, to know that everything ends, including the universe that birthed us. To carry that knowledge not just as intellectual abstraction, but as emotional reality, as the existential backdrop against which all human drama plays out. Does this knowledge crush you with its weight? Or does it liberate you? Does cosmic mortality render human endeavors meaningless? Or does it imbue them with urgent significance? Perhaps both. Perhaps the recognition that everything, even the universe itself, is temporary, makes each moment both vanishingly insignificant and infinitely precious. Like a symphony building toward its final note, the cosmos acquires its meaning not despite its ending, but because of it. Without conclusion, there can be no wholeness. Without death, no shape to life. And so we return to your breath. That simple, rhythmic exchange that connects you to stars long dead and to futures yet unborn. Each inhalation draws in atoms that have existed since the Big Bang. Each exhalation releases them back into the cosmic flow. You are not separate from the universe and its fate. You are a brief eddy in its currents, a momentary pattern in its unfolding. What does the death of everything mean for the way you live today? How does cosmic mortality illuminate human mortality? Does knowing the universe will eventually grow dark and silent make your own brief flicker of consciousness more tragic or more miraculous? There are no universal answers to these questions. Each conscious being must find their own response to the cosmic abyss. But perhaps there is meaning in the asking, in the very fact that the universe has evolved creatures capable of contemplating its end. Perhaps we are how the cosmos comes to terms with its own mortality. So take another deep breath. Feel your connection to everything that is and ever will be. And as we venture further into the mystery of how everything ends, remember, you are not merely audience to this cosmic drama. You are part of it. Its fate is your fate. Its mystery is your mystery. and in the face of eventual darkness, you have the capacity to create light, however briefly it shines. As we approach the end of our journey, the stars begin to fade. One by one, they flicker out across the cosmic canvas, not randomly, but in patterns. Constellations disintegrate. Galaxies dim. The universe grows darker with each passing moment, not just in our distant future, but here, now, in the theater of your imagination. What if everything we've discussed so far, every theory, every prediction, every model of cosmic death, is fundamentally wrong? Not because our mathematics is flawed or our observations incomplete, but because we've misunderstood the very nature of what we're observing? Here is the disturbing possibility that haunts the dreams of cosmologists. What if the universe is already dead, and we are just experiencing its echoes? Consider this. When you look at a distant galaxy, you're seeing it not as it exists now, but as it existed millions or billions of years ago. The light from the Andromeda galaxy takes 2.5 million years to reach us. The cosmic microwave background, our most distant observable signal, shows the universe as it was 13.8 billion years in the past. We never see the cosmos as it is, only as it was. What if, in the true now of the universe, a moment we can never directly observe, catastrophe has already struck? What if a vacuum decay bubble has already formed somewhere in the distant cosmos, racing outward at the speed of light, rewriting the laws of physics in its wake? We would have no way of knowing until it reached us. No warning, no signal. One moment existence, the next, something else entirely. Or consider a more subtle variation of this horrifying thought. What if we're mistaking the cause for the effect? What if what we call the expansion of the universe is actually its final contraction viewed from the wrong temporal perspective? Imagine reality as a vast cosmic film playing backward. What looks to us like expansion toward heat death might actually be the final moments of a collapsing universe, the entropic reversal of a big crunch. We perceive it as moving toward disorder because we ourselves are part of the same thermodynamic process, our arrow of time aligned with the cosmic flow. But what if our consciousness, our perception of now, is just a peculiar eddy in this flow? What if we're watching the universe die while believing we're witnessing its middle age? The mathematics allows for this possibility. General relativity treats time as a dimension, not a flow. The distinction between past and future emerges from entropy, not from any fundamental asymmetry in physics. The equations work equally well in either temporal direction. Now, look outward. The deepest space telescopes reveal galaxies racing away. From us, their light stretched to red by cosmic expansion. But those same equations might describe a universe contracting toward a final singularity, with light compressed toward blue, except that we, as part of this process, perceive it in reverse. Perhaps the universe isn't dying in the future. Perhaps it died in the past. And what we experience as reality is something stranger, the cosmic equivalent of the brief electrical surges that occur in a human brain at the moment of death. The entire 13.8 billion year history of our universe might be the cosmic analog of those few seconds when a drowning person's life flashes before their eyes. Watch as galaxies collide in slow motion, their spiral arms unwinding like giant celestial clockworks. Stars explode in silent supernovae, casting elements into the void. Black holes devour entire stellar systems, their event horizons expanding, like hungry mouths. These aren't just events in cosmic history. They may be the final memories of a universe that has already ended. And this leads us to an even more profound possibility. What if the universe's death isn't a future event, but a boundary condition, like the edge of a cosmic map? What if the end exists simultaneously with the beginning and the middle, in a reality where time is not flowing but simply is? In this view, we don't move toward the death of the universe. We exist as part of an eternal structure that includes its death as one of its features. Like characters in a novel who cannot know they're approaching the final page because they exist on all pages simultaneously, we perceive change and progression where there may be only completeness. The universe, then, never dies in the sense of transitioning from existence to non-existence. It simply is, complete, whole, containing its end as surely as it contains its beginning and middle. But there's yet another possibility, one so vast and strange it challenges our deepest intuitions about reality. What if death itself is an illusion born of limited perspective? What if the universe neither begins nor ends, but transforms, not once, but endlessly, not in time, but outside it? Theoretical physicists have proposed models where our universe exists as a four-dimensional brain floating in a higher-dimensional bulk space. Other brains, other universes with their own physical laws, might exist parallel to ours. Occasionally, these brains might collide, their impact releasing enormous energy perceived within each brain as a Big Bang. In this scenario, what we would call the death of our universe might simply be its collision with another brain, an event simultaneously destroying one configuration of reality while creating another. Not an ending, but a transition so fundamental it transcends the categories of beginning and ending altogether. Galaxies swirl like luminous whirlpools against the dark canvas of space. Stars pulse with nuclear fire. Planets orbit in stately procession. All this grandeur, all this complexity. Perhaps it's not marching toward oblivion, but dancing in an eternal cosmic ballet, where death and birth are the same movement, viewed from different perspectives. Think of water. It freezes into ice, melts into liquid, evaporates into vapor, changing form without ever changing essence. Perhaps the universe undergoes similar phase transitions, its fundamental nature preserved even as its manifestation transforms utterly. What dies, then, is not reality itself, but merely one configuration of it, one temporary pattern in an eternal process of cosmic evolution. What we fear as the end may simply be a metamorphosis beyond our current comprehension. But for us, for consciousness as we know it, this transformation would still be an ending. The specific conditions that allow for stars, planets, biology, and minds would cease. The universe that makes our existence possible would perish, even if some deeper substrate continues in altered form. And so we return to the question that began our journey. How will the universe really die? Having traveled through labyrinths of theory and speculation, we can now offer not an answer, but a realization. The death of the universe isn't just something that will happen to reality, it's something that happens within reality. It's not external to existence, but woven into its very fabric. Just as your mortality isn't something separate from you, but an intrinsic aspect of your being, cosmic death isn't the universe's fate, but its nature. And here's the final, haunting possibility. If the many worlds interpretation of quantum mechanics is correct, if every quantum event spawns parallel realities, then the universe doesn't die once. It dies in infinitely many ways across infinitely many timelines. In some, it freezes. In others, it collapses. In still others, it rips apart or undergoes vacuum decay or transforms into something beyond our categories, which means that somewhere in the vast multiverse, A version of you is always witnessing the end of everything. And somewhere else, another version is always witnessing its birth. Every possible cosmic fate is happening simultaneously across the infinite tapestry of quantum reality. If space is truly infinite, as some models suggest, then the observable universe is just a tiny bubble in an endless sea. In an infinite cosmos, anything that can happen must happen. Not just once, but infinitely many times. Every possible arrangement of matter and energy must recur, including exact duplicates of Earth, of human history, of you. Which means this: if the universe is infinite, then somewhere out there, impossibly far beyond our cosmic horizon, another version of you is watching this very same video right now. And another, and another. An infinite series of yous, experiencing the same moment, asking the same questions about cosmic mortality. The death of everything, it seems, is both inevitable and impossible, depending on how broadly we define everything. Our universe will die. But perhaps the multiverse, or whatever deeper reality undergirds existence, simply cannot cease to be. And so we end where we began, with a paradox. The universe is dying. The universe is eternal. Both statements may be true, their apparent contradiction merely an artifact of our limited perspective. Like the blind men touching different parts of an elephant, we mistake our partial grasp for complete understanding. Perhaps the true nature of cosmic mortality, like the true nature of consciousness or the origin of existence itself, lies just beyond the horizon of human comprehension, not because we haven't yet discovered the right equations or made the right observations, but because our minds evolved to navigate the mesoscale world of predators and prey, not to grasp ultimate reality. And yet, in striving to understand how everything ends, we participate in one of the universe's most remarkable achievements: self-awareness. Through us, through our science, our art, our wonder, the cosmos contemplates its own mortality. Whatever the ultimate fate of reality, this moment of cosmic self-reflection is surely one of its most extraordinary features. Look up at the night sky one more time. Those distant points of light, many already extinguished, their final photons still racing toward your eyes, are both harbingers of cosmic death and testaments to its grandeur. In their silent radiance lies the universe's most profound message. Even endings can be beautiful. We began with a simple question: how will the universe really die? Yet our journey has revealed that this question, seemingly straightforward, contains multitudes. Like a cosmic Russian doll, each answer we've uncovered has contained new questions within it. Each revelation has spawned deeper mysteries. We've traversed vast territories of thought, from the mathematical landscapes of quantum mechanics to the philosophical precipices of existence itself. We've contemplated heat death and vacuum decay, multiverses and brains, entropy and information. We've gazed into abysses so profound they challenge not just our answers, but our questions themselves. And perhaps that's the point. Perhaps the question of cosmic mortality isn't meant to be definitively answered but continually explored. Each generation adding new perspectives, new mathematics, new observations that transform our understanding in ways we cannot predict. The death of the universe isn't just a future event to be calculated, but a conceptual horizon that pushes us to expand our thinking. It forces us to confront scales of time and space that human minds never evolved to comprehend. It compels us to question our most basic assumptions about reality, causality, and existence itself. Think of how far our understanding has come. A century ago, we didn't know other galaxies existed. 70 years ago, we didn't know about the Big Bang. 30 years ago, we didn't know the universe's expansion was accelerating. What fundamental discoveries await us in the decades and centuries to come? What transformative insights might reshape our cosmic narrative once again? Perhaps we're on the verge of a conceptual revolution, as profound as quantum mechanics or general relativity. A new framework that will make our current debates about universal death seem as quaint as ancient arguments about celestial spheres. Perhaps the true nature of cosmic mortality lies not in any scenario we've discussed, but in possibilities we haven't yet imagined. This is not to surrender to mysticism or to suggest that scientific inquiry is futile. Quite the opposite. It's precisely because science has been so successful at expanding our understanding that we can appreciate how much remains unknown and how magnificent the quest to know truly is. Consider the instruments we've built to peer into cosmic mysteries, telescopes that capture light from the edge of the observable universe, detectors sensitive enough to measure the collision of black holes billions of light-years away, particle accelerators that recreate conditions not seen since moments after the Big Bang. These aren't just technological achievements, they're extensions of our cosmic curiosity, embodiments of our determination to understand our place in existence. And each new instrument, each new observation, each new calculation brings us closer to truths that our ancestors couldn't have imagined. The accelerating expansion of the universe, now central to our understanding of cosmic fate, was unknown until the late 1990s. What comparable discoveries might await us? What fundamental aspects of reality might we currently be missing? But this is not just a scientific question, it's a human one. How we think about the death of everything shapes how we think about our own brief lives. If the universe itself is mortal, if even galaxies and black holes and the fabric of space-time must eventually perish, what does that mean for our search for meaning, for our art, our ethics, our aspirations? Some find nihilism in cosmic mortality. A universe doomed to extinction seems to render human striving pointless. But perhaps there's another perspective. Perhaps it's precisely because everything ends that anything matters at all. Perhaps mortality, cosmic and personal, doesn't diminish meaning, but creates the conditions for it to exist. A symphony without a final note would not be eternal music, but endless noise. A story without conclusion would not be an everlasting narrative, but an incoherent jumble. Perhaps the universe requires an ending to have meaning, not meaning imposed from outside, but meaning emergent from its structure, its evolution, its brief flowering of complexity amid eternal simplicity. And what if consciousness, the awareness with which you're processing these words right now, is the universe's way of creating meaning from its own mortality? What if awareness itself is how the cosmos responds to the fact of its eventual extinction? Through minds like yours, the universe doesn't just exist, it knows it exists. It doesn't just change, it understands change. It doesn't just die, it contemplates its death. You, reading this now, are not separate from these cosmic processes. The boundary between you and universe is more permeable than it appears. The atoms in your body were forged in stellar furnaces. The energy animating your thoughts was present at the Big Bang. The mathematical laws governing your brain's electrochemistry are the same laws that govern quasars and quantum fields. In the deepest sense, you are not in the universe. You are the universe, or at least a small portion of it, that has evolved the remarkable capacity to wonder about itself. Your questions about cosmic death are the universe's questions about itself. Your awe at the vastness of time and space is the universe's self-recognition. And here's a chilling thought to consider as our journey nears its end. What if the death of the universe is not something that will happen to us, but something that is happening through us? What if consciousness itself, the emergence of minds capable of asking these questions, is part of how the universe dies? Not in the literal sense of causing cosmic extinction, but in the sense of being part of the process by which complexity peaks before the long descent into simplicity. What if awareness is the universe's midlife crisis, its recognition of its own mortality triggering a brief, extraordinary flowering of self-reflection before the long silence? Or, more unsettling still, what if we've misunderstood the relationship between consciousness and reality entirely? What if the universe, as we know it, with its galaxies and laws of physics, its beginnings and endings, exists not independently, but as a construct of consciousness itself? What if reality is more like a shared dream than an objective structure, and its death more like an awakening than an extinguishing? These questions may seem to veer from science into philosophy, but the boundary between these domains grows increasingly porous the deeper we probe into cosmic mysteries. The nature of time, the role of the observer, the meaning of information, these concepts straddle the border between physical theory and metaphysical inquiry. The death of the universe may ultimately be as much a philosophical question as a scientific one. And so we invite you not just to consume these ideas, but to engage with them, to wrestle with them in your own mind, to discuss them with others, to read the research, follow the debates, contribute your own perspectives. The story of cosmic mortality isn't finished. It's still being written, not just by scientists and philosophers, but by everyone who contemplates these questions. What do you think happens when everything ends? Does the prospect of cosmic extinction terrify you or fascinate you? Does it alter how you view your own brief existence? There are no correct answers to these questions, only different ways of relating to the greatest mystery we can contemplate. Perhaps the most profound realization is this: whatever the ultimate fate of the cosmos, you are witnessing its journey. You exist in a universe aware of itself, capable of discovering its own laws, predicting its own evolution, contemplating its own mortality. That fact alone, that convergence of existence and awareness, may be the most extraordinary feature of reality, regardless of how or when it ultimately ends. As you go about your day after encountering these ideas, as you work and eat and talk and sleep, remember that you carry within you atoms that will witness the death of the last stars. The fundamental particles that compose your being will be present, in some form, at the final moments of cosmic history. There is a direct, unbroken physical connection between your body and the ultimate fate of everything. You are, in a very real sense, immortal, not as a continuous consciousness, but as components of a cosmos whose patterns shift and transform without ever truly vanishing. Energy cannot be created or destroyed, only changed in form. The essence of what you are will persist through cosmic deep time, experiencing the death of the universe not as an observer, but as a participant. And perhaps that's the most awe-inspiring thought of all: the boundary between witnessing the death of everything and being that death may be illusory. We are not separate from the cosmic processes we study. We are those processes, temporarily organized into thinking, feeling forms, but ultimately one with the universe whose fate so captivates us. The cosmos is not just our home, but our substance, not just our origin, but our destiny. Its mortality is our mortality. Its mystery is our mystery. Its story, still unfolding across vast expanses of space and time, is our story. And so we end not with an answer, but with an invitation. Keep looking up. Keep asking questions. Keep allowing yourself to be awed by the grandeur of existence and humbled by its mysteries. The universe may be mortal, but curiosity doesn't have to be. Scientists 1,000 years from now may have totally different conceptions of cosmic death than we do today. The universe itself might surprise us with discoveries that transform our understanding entirely. The final chapter of existence has not been written, and perhaps cannot be written until it unfolds. That uncertainty isn't a failure of knowledge, but an opportunity for wonder. It's not an absence of answers, but a superabundance of possibilities. It's not a reason for despair, but an invitation to keep exploring, to remain open to the vastness that exceeds our understanding. So take these ideas with you. Let them work on your mind. Let them alter your perception of the night sky, of time, of your own brief but magnificent existence. Let them remind you that you are part of something unimaginably vast and mysterious, something whose ultimate fate remains one of the greatest questions we can ask. The universe may be dying, but as long as there are minds to contemplate that fact, to be moved by it, challenged by it, transformed by it, something essential lives on. Perhaps consciousness itself is the universe's answer to mortality, not a solution, but a response, not an escape, but a reckoning. And perhaps that's enough. Because in the end, the death of the universe isn't just about how everything finishes. It's about how everything matters along the way. It's about the meaning that emerges from transience, the value created by impermanence, the poignancy that arises from the knowledge that even the cosmos itself is fleeting. The universe will end. Of that, we can be reasonably certain, even if the precise mechanism remains debatable. But the wonder it inspires, the curiosity it provokes, the awe it generates in minds capable of contemplating it, that may be the one thing that never truly dies.